triangles part 2. In the first episode we covered the Pythagoras theorem, and we also identified the limitations of the Pythagoras theorem, where we say the Pythagoras theorem is only applied when you have two sides. When you're given two sides in a right angle triangle. So the other cases will be solved by trigonometrical ratios. By trigonometrical ratios, what are we making reference to? Trig ratios. Our trig ratios, we have 3 trig ratios. We have the cosine, sine, and tangent. So in a right angle triangle, the longest side is called the hypotenuse. And let's say our angle in question, we mark it as theta. So the opposite side to the angle in question is the opposite side, and then the side which is adjacent to that angle, adjacent. Let me redraw the right angle triangle again, and change the angle. The longest side does not change, the hypotenuse remains the same, but now here the opposite side is different because the angle is now different. So this side will be the opposite side, and then the adjacent side. So what you can see from the two right angle triangles is that the adjacent and the opposite sides, they always change depending on the given angle. So we are going to use the acronym. Acronym to simplify this will be ChaShoTao. C for cosine, S for sine, T for tangent. And when we read this, we read from right to left. So we are saying cosine theta will equal to adjacent over hypotenuse. Adjacent over hypotenuse. Sine theta will equal to opposite over hypotenuse. Opposite over hypotenuse. Then tan theta will be equal to opposite over adjacent. Opposite over adjacent. So let's apply the trig ratios in solving a given problem. So let's say you're given a right angle triangle, and this angle is said to be 40 degrees, and the side is not known, and then the adjacent side is given as 9. Now, how do you determine which trig ratio to make use of? So here we look at the given angle, and the side in question is opposite, and the given side is 9, which is adjacent to the given angle. So we have opposite and adjacent. We go to the acronym. Which trig ratio relates opposite and adjacent? You see, that's tan. So we're going to make use of tan. That's how you pick the trig ratio which you use to solve given a particular given angle, triangle. Sorry. So tan 40 will be equal to opposite x over adjacent. Solving the equation, we cross multiply, becomes x is equal to 9 times tan 40. And you punch on your calculator. Take note, make sure that your calculator is in degrees. On top of your screen on your calculator, it must be written DEG, which is degrees. So 9 tan 40. 9 tan 40 will be equal to 7.55. To 3 significant figures, your answer will be equal to 7.55. Let's have another example. So that was example 1. Let's have example 2. Then again, right angle triangle. 45 degrees, it's 10. How would you determine which trig ratio you are going to use? The side in question is opposite to the given angle, and the other side which is given is the hypotenuse. So the question is which trig ratio relates opposite in the hypotenuse? Opposite in the hypotenuse, that's sine. So we say sine 35 degrees is equal to the opposite over hypotenuse. We cross multiply, it becomes 10 sine 35. Again, you punch on your calculator, make sure the calculator is in degrees. 10 sine 35, that gives us 5.74 to 3 significant figures. 5.74. Let's say with another example, example 3. You are given again right angle triangle, and the angle, given angle is 25.8 degrees. Y is 15. So the question is, how do you determine which trig ratio which you are going to use? The question, the side in question is the adjacent side, and the given side, that's the hypotenuse. So you go back to the acronym and check which trig ratio relates adjacent in the hypotenuse. You see, that's cos adjacent over hypotenuse. So we say cos 25.8 degrees is equal to adjacent over hypotenuse. Cross multiply, it becomes 15 cos 25.8. So 15 cos 25.8, that gives us 13.5. 13.5. Now we want to look for a question where we apply almost all the trig ratios. Let's see if it's our example 4. Example 4. Make use of this side. So example 4, we are given two right angle triangles. It's 45 degrees, and this side is A, B. That angle is given, and that side is given is 25 centimeters. So we are required to find the values of sides A, B, and C. So we first work with this triangle. In that triangle, we can get the value of A. The value of A is adjacent to the given angle, and then we're given the hypotenuse. The question again, which trig ratio are we going to use which relates adjacent and the hypotenuse? We come back to the acronym. Adjacent and the hypotenuse, that's cos. So we say cos 26.2 degrees equal to adjacent over hypotenuse. So A is equal to 25 cos 26.2. So 25 cos 26.2, we get 22.4 centimeters. Part 2, for us to get the value of B. B is opposite to the given angle, and then we have the hypotenuse, which trig ratio relates opposite in the hypotenuse. We come back again to the acronym opposite in the hypotenuse, that's sine. We then say sine 26.2 degrees is equal to opposite over hypotenuse. So B is equal to 25 sine 26.2 degrees. So 25 sine 26.2, we get 11. That's 11.0 centimeters. Then the last one, that's for C. Remember, now we have the value of A. We can say C is opposite to the given angle 45 degrees, and then A is the hypotenuse. Opposite and hypotenuse, that's what the sine. So we say sine 45 degrees is equal to opposite, which is C over hypotenuse A. Opposite C over A. Remember, our A is equal to 22.4. So we cross multiply and our C becomes 22.4 sine 45 degrees. So 22.4 sine 45 degrees gives us 15.8 centimeters. So we have done tan, sine, cos, and our last example we made use of cos and sine. Now the next question is, how about we have been finding the missing side. How about when we are required to find the missing angle? Let me just give two examples. Two examples for that. For all these cases, I think you've seen that we've been finding the missing side. How about for angles? Let's take another example. Say you're given this right angle triangle and the missing angle. You're given two sides. So here, the missing angle, the side which is opposite to the missing angle, that's 4, and adjacent. So we have opposite and adjacent. We make use of tan. So it becomes tan theta is equal to opposite, which is 4, adjacent 9. So theta will be equal to, this is arctan 4 over 9. On your calculator, if you want to access the function tan to the power minus 1, which is arctan, you access it via the second function. So that's your second function on the pattern of tan. So you say second function tan 4 over 9. That gives us 23.96. So to one decimal place, that becomes 24.0. Let's have another example for angles. So this one, let's say that angle is marked with beta, the other one is alpha. You are given two sides. Let's say this side is 5 and the hypotenuse is 12. So you are required to find the value of alpha and beta. So first part 1, let's find the value of alpha, angle alpha. That side will be adjacent side and the hypotenuse. Trig ratio which relates adjacent and hypotenuse, that's cosine. So we're going to say cos alpha is equal to adjacent over hypotenuse. So for you to get the angle, it now becomes cos 5 over 12. For you to access the function cos on your calculator, you access it via the second function. So that's the second function on the button of cos. So second function cos 5 remainder 12. We get 65.4 degrees. Part 2, for angle beta, you don't necessarily need to make use of any of the trig ratios. Remember, in a triangle, angles in a triangle they add up to 180 degrees. But for a right angle triangle, another concept or a principle, remember this angle is equal to 90 degrees. So all the angles in a right angle in a triangle they add up to 180 degrees. 180 degrees minus 90, that's 90. So always in a right angle triangle, these two angles they add up to 90. So when you're given one of the two angles, for you to get the missing angle, in this case that will be beta, you simply say 90 minus 65.4 degrees. So beta is equal to 90 minus 65.4, which gives us 24.6 degrees. So that's all to do with right angle triangles. We said we solve right angle triangles by the Pythagoras theorem and then trigonometrical ratios. Take note of this. When you're dealing with right angle triangles, that's when you use the Pythagoras theorem. But when the triangle is not a right angle triangle, you cannot make use of the Pythagoras theorem. You cannot make use of ChaShoTao, the trig ratios. You make use of something else. I think we touch on that in the next series. So basically that's what we do with right angle triangles.